Welcome back to question 2 of this series where we learn how to calculate concentrations. We ended off with question number 2, which reads, a solution is prepared by dissolving 50.4 grams of sucrose in 0.332 kilograms of water. The final volume of the solution is 355 milliliters. For this solution, we need to calculate the 5 things that we calculated in question 1, namely molarity, molality, percent by mass, mole fraction, and mole percent. Let's begin with molarity. I've written down the definition of molarity. It's the moles of solute per the volume of solution, and we represent it with this M letter. So let's begin by finding the moles of the solute. The solute here is sucrose. It's what's being dissolved in the water. To find the moles of sucrose, we have to start by calculating the molar mass of sucrose. Luckily for us, they've provided the molecular formula. So I'll start by finding the molar mass of one molecule of sucrose. To do that, I'll take the molar mass of one individual atom of carbon, which is 12.01, multiply it to 12, because there are 12 atoms in one molecule. The molar mass of hydrogen is 1.01 times 22, and oxygen is 16.00, and we'll multiply that by 11. So we'll take the product of each of these, add them up, and that will give us the molar mass of one molecule of sucrose. Let's quickly use our calculator. 12.01 times 12 plus 1.01 times 22 plus 16 times 11, and we end up with 342.34 grams per mole. Now to find the number of moles, I'll take the reciprocal of this ratio, so I'll have 1 mole at the top, and at the bottom I'll write down 342.34 grams, and I'll multiply this by the mass of sucrose, and that's provided in the question. Watch what happens when I multiply it by 50.4. This unit and this unit cancel out, leaving us with moles. Let's go ahead and record that number. 50.4 divided by 342.34, and we end up with 0.14722 moles. And we do have to take into account significant figures. Our final answer should have 3 significant figures, but I've recorded more than 3 digits here just so that I don't run into any rounding errors. I'll put a dot right underneath the 7 so I don't forget. So that's the number of moles of the solute. We'll take this number now and divide it by the volume of the solution. The volume of the solution is 355 milliliters. Converted into liters, that's 0.355 liters. So I'll divide this by 0.355 liters. And in case you're curious as to how I got this, remember that 1,000 milliliters is equal to 1 liter. So I'll divide this number now by 0.355, and we end up with 0.41, and since we have to stop at 3 significant figures, that 4 becomes a 5 because it's followed by a 7. So 0.415. 0.415 molar. And feel free to write down moles per liter, it's the same thing. So we just found the molarity, now we'll find the molality. And for that, we have the definition right here. Moles of solute, which we already found, was this, divided by the mass of the solvent. The mass of the solvent is right here. So using the information from question A, I can easily find the molality, 0.14722 moles, divided by, this time, the mass of water, which is 0.332. Let's use our calculator. 0.14722 divided by 0.332, and we end up with 0.4434. 4 rounded to 3 significant figures. We'll discard that 4, and this number right here represents our molality. And you can also represent this with a small letter m. Let's move on to C. We want to find the percent by mass. Now, for that we need the mass of the solute that was given to us right here, 50.4. 50.4, and the units were in grams. And we also need the mass of the solution. We already know the mass of water. It's 0.332 kilograms. I can change that right now into grams. It's 332 grams, or 332 grams. And we'll add 50.4 grams also, which is the solute's mass. And this makes up the mass of the solution. So let's find the answer to that and then subsequently multiply it by 100 because this is a percent. So 50.4 divided by 332 plus 50.4, and we end up with this number multiplied by 100, rounded to 3 significant figures. We should end up with 13.2%. 13.2%. For part D, we need to find the mole fraction. So we use the moles of the solute, which we obtained in question A. It was 0.14722 moles divided by moles of the solution. To find the moles of the solution, we first have to find the moles of sucrose, which we already did. Dividing these two, the quotient gives you that. But we also need to find the moles of water. So let's go ahead and do that right here. The chemical formula for water is H2O. So we have 1.01 times 2 to represent the molar mass of hydrogen, plus the molar mass of one atom is 16.00 for oxygen. Adding these up, we should end up with 18.02 grams per mole of water. That's the molar mass of water. I'll write this down underneath. 18.02 grams per mole is the molar mass of water. We also discovered this in question 1. And remember that the mass of water was 0.332 kilograms. Converted into grams is 332 or 332. I'll flip this where I have 1 mole at the top and 18.02 grams at the bottom. Multiply that by 332 grams. Watch this. This unit and this unit cancel out. Using our calculator, 332 divided by 18.02, that is equal to 18.4239, plus the moles of the solute, which is right there, 0.14722 moles, and this will give us a fraction, 0.14722 divided by the sum of the denominators. And that's the number we get, which is equivalent to 0.00792. That's the answer for D. And if we want the answer for E, we multiply this by 100%. That gives us the percentage. So multiply that by 100%, and we end up with 0.79 to 3 significant figures, 3. And also, this should have been a 3 as well, because we were rounding to 3 significant figures. And there you have it. That is how to calculate different forms of concentration.